Okie dokie, so the chain rule and tangent. So basically, when we're finding tangents, we are differentiating the curve, okay? So when we've got a really nasty curve, we can use the chain rule to differentiate it, and then do some stuff with that derivative to work out some specific tangents, like when a tangent has a gradient of a specific, a specific gradient, okay? So the big ones that we're wanting to be looking for are for when the tangent is horizontal. Okay, so if the tangent is horizontal, then we know one specific thing about it, and that is that the gradient is 0. Because if you have a think about it, okay, if I draw like a curve like this, okay, if I was to draw tangents along this, okay, at specific points, the only place where it is horizontal is where we have a turning point, okay, and the gradient is 0. So, pretty straightforward stuff. Let's jump into an example and see how this actually works. So what we're going to do is we're going to differentiate y is equal to 4 minus x to the power of 4, or to the power of 5, and hence find the points of the curve where the tangent is horizontal. So what we're going to start off by doing is we're going to let y be equal to 4 minus x to the power of 4 to the power of 5. Okay, so by doing so, we can then let u be equal to 4 minus x to the power of 4, and therefore y will become, it's going to be u to the power of 5. So once we've done that, we can do du dx, so differentiating u with respect to x, and we're going to, the 4 is going to disappear, okay, we're going to be left with minus 4x cubed, and we're going to differentiate y with respect to x. On this side, I'm going to get 5u to the power of 4. Okay, once we've done that, we can then put it together. So dy dx is equal to dy du times du dx, which is our chain rule. So putting these together, dy du is equal to 5u to the power of 4 times negative 4x cubed. Okay, so once we've done that, we put it together and we get negative 20x cubed u to the power of 4. Okay, then we substitute our u back in to get what our derivative value is. And in this case, it's going to be 4 minus x to the power of 4. So we're going to get minus 20x cubed. Okay, and then it's 1 minus x to the power of 4. Or is it 1 or do we do 4? We got 4. 4 minus x to the power of 4 to the power of 4. Okay, so that's our derivative. Now, once we've found our derivative, we want to work out, well, now we want to work out where the tangent is horizontal. So for the tangent to be horizontal, then dy dx needs to be equal to 0. The gradient of our derivative needs to be equal to 0. So in other words, we need 0 to be equal to minus 20x cubed, lots of 4 minus x to the power of 4 to the power of 4. Now, this looks a lot trickier than what it actually is, okay? We're trying to find where we have powers of 0. So we're going to have powers of 0 whenever this is equal to 0 or whenever this is equal to 0. So we're going to have this equal to 0 when minus 20x cubed is equal to 0, or when 4 minus x to the power of 4 is equal to 0. Okay? So, with that being said, we can now work out when our points are equal to 0, when our derivative is equal to 0. Okay, so minus 20x to the power of 3 is equal to 0. So that is when, well, there's only one place when that's equal to 0, and that's at 0. Okay, so that one's nice and easy. Now this one we might need to do a little bit of working out. So what I'm going to do is I'm going to subtract 4 from both sides to get minus x to the power of 4 is equal to negative 4. And then we're going to multiply both sides by 4. And then I'm going to take the 4th root of both sides. So 4 of 4. Okay. Now your direct instinct might be to say, well, that's just equal to 1, but it's not always going to be the case. So we need to just double check. 4 to the 4 is 1.41, or in other words, I'm pretty sure that's the square root of 2 from memory. 2 to 2, let me have a think. It's going to be 4 to the 1, 4. Yeah, we'll just round it. X is equal to 1.4142. Actually, I might just double check that because I think that might be right. 1.41. No. 41421356213562. Yeah, it is. Okay, so that's equal to the square root of 2. Okay, so those are our x values for where the tangent is equal to 0, but we need to find the points. Okay, so we need to find the points on the curve where the tangent is horizontal. So once we found our x values, what we're going to do is we're going to resubstitute them back into this original equation. So the y is equal to 4 minus x to the power of 4 function. So we're going to go y is equal to 4 minus x to the power of 4 to the power of 5. So what we're going to say is tangent is horizontal at x is equal to 0 minus root 2 and root 2. So find y values by substituting into y equals to 4 minus x to the power of 4 to the power of 5. So at x is equal to 0, y is equal to, so it's going to be 4 minus 0 to the power of 4 to the power of 5. So y is equal to, so 4 minus 0 is just 4, so it's 4 to the power of 5. So y is equal to, okay, let's put this one in. So 4 to the power of 5, it's 1024. So it's really high, 1024. Okay, at x is equal to root 2, y is equal to 4 minus the square root of 2 to the power of 4 to the power of 5. So y is equal to, well, let's put that one in. I think that should be equal to 0, if I am not mistaken. 4 minus the square root of 2 squared to the power of 5. Nope, 32. That should be a 4, not a 2. That's why that one's wrong. Whoopsies. Yeah, 0. What I thought. Okay, so that point is at root 2, 0. And our third one at negative root 2. Okay, y is equal to 4 minus the negative root 2. Remember to put this in brackets this time, otherwise it's not going to do it properly. Okay, so we're going to go minus the square root of 2 to the power of 4, and that one's also equal to 0. So, therefore, the tangent of the curve y is equal to 4 minus x to the power of 4 all to the power of 5 are horizontal at 0, 1, 0, 2, 4. This one is root 2, 0 and negative root 2, 0. Okay, so that's all we need to do for that one, but what we might do is we might have a look at Desmos just to clarify that that is the case for this function. So we've got y is equal to 4 minus x to the power of 4 all to the power of 5. Okay, and so we look at this. And we say, okay, where is the horizontal? So if you have a look at this one here, we've got a pretty flat at about 1.41. Yep, so there it is there. That's my flat point there for that side. On this side, I've got another flat point as well, which is that one there. So again, it's approximately at 1.4142, which is the square root of 2. Okay, now what I'm going to do is I'm going to bring this scale in quite a bit so that we can see at 10240. So there it is right there. That's our other horizontal. So if I was to draw a line at, that's y is equal to 1024, that makes a horizontal line or a horizontal tangent to that point there. Okay, so really cool stuff. And that's pretty much how we do this there's the other one, 0. And that's how we find out a specific point, or a specific value for our gradient of our tangent. So horizontal is a big one because we're always concerned about where the horizontals are, but this could work for anything. We could ask you to do it for 1, we could ask you to do it for 3, we could ask you to do it for negative root 217. Like, it doesn't matter what the number is. Typically, and it's going to be easier if we ask for the horizontal one, because again, the horizontal one is the one that we're usually more concerned about, okay? And B, when you're, doing all this factorizing and stuff for zeros, when you're doing all this factorizing stuff, it's much easier to find solutions for 0 than it is for other ones. However, if you have been given a number that's a non-zero, you might need to take it to the other side so that you get a quadratic or quadratic type thing equal to 0 and then factorize it that way. With that being said, however, that is going to be the end of this video, and we're going to have a look at parametrics in our next one. So that is when our curve is a parametric equation.